Hello. Today we're going to open what's in this box. What is supposed to be in here? I'll tell you. So many of you have been following my journey, my very long journey about how I called it the tone hinge, and it's covering the CNC machine that I have out in my shop for doing wood routing, and I built it up to do various prototyping as well as make these speaker cabinets for the top of my Valve Studio shelf here. I've decided that I don't want to be doing constant Gerbil type development for my custom hardware design that I have out in the shop. I'm just going to bite the bullet, and I went and bought some Masso CNC controllers. I'll have the link down in the description. These things have been out for several years. This is currently the G3 version, which is the third generation of the Masso controller. And this supports a touchscreen as well as jog wheel and a bunch of inputs. I think it has the ability to do 24 inputs and 18 outputs. It's really quite flexible, and I got the 3-axis software version. This also will support a 4 and a 5-axis for an additional, I don't know, $30 or $60 fee for me to upgrade the firmware in my box. So I am going to replace everything I did out in the shop for my Hyatt machine with a Masso controller, and we're going to go down, take a slight detour on the tone hinge journey and update my electronics, because what I was finding was every time I went out to make a part, I ended up revving the firmware for whatever reason, and I'm just tired of building tools. I want to build the product. So I built this. I can't change the firmware in this. I get what I get. And let's see what I do get. So I'm going to go ahead and unbox this, and we'll see, you will see at the same time I do what comes in the Masso box. Alright, let's head over to the bench and do the unboxing. Okay, I'm here on the bench. I've got the shipping label cut out, and I'll go ahead and cut the tape. So let's go ahead and open this for the first time. Let's go ahead and open this up. We have our packing invoice here. And I have two of these, like I said. This one's for my business partner, and this one's for the Hyatt machine in the garage. So let's go ahead and see what's in one of these boxes. And this particular box I bought from US Distribution, which is CNC for PC here in the United States. They're in Florida. And I got the base unit for 3-axis for $630. And you might think that's a lot coming from the Gerbil world, but it's actually not. If you think about, okay, let's say I want to have the same functionality with a touchscreen, a 3-axis machine that's reliable with a bunch of inputs, reliable connections for doing everything. It's flexible, gives me room to grow in the future, have a lot of different types of I/O for whatever I want to control in my machine. So if you want to add up the Gerbil board, the drivers, the the computer to run it on, you know, you're going to need Windows or some kind of OS. You're going to need to support that. You're going to need the GUI, whether you have touchscreen. Then you have to have like a laptop that you want to have in a dusty environment. And I just didn't want any of that. And it, like I said, it turns out every time I went and worked on a project, I'd end up revising the firmware in my Gerbil board, and I was like, I'm tired of making tools. Let's make some products here. Just a reminder, I'm not using stepper motor drivers. I could. This supports that, but I'm actually using these JMC motors. These are step servos, so they have the drive electronics built in here. The interface is just the same as talking to a stepper motor, except the driver's right here. And the additional thing that this has is an optical encoder, which keeps it on the same step pulse, and you can send pulses to this at a really high rate. And if you look at this chart here, you probably can't see this, but the latest, the highest resolution is 40,000 steps per 40,000 pulses per revolution, which is quite a bit of resolution out of this little motor here. So with the encoder and the micro stepping hardware that they have in here, you can achieve really unbelievable amount of resolution with these things. Gerbil actually will do step frequencies up to about 30 kilohertz. This will do them up to 115 kilohertz. So let's go ahead and open up the box. It's a really nice box. It's got my serial number here. So we open this up, and right here we have QR codes for documentation, the forums, and the videos. You can see that we're well padded on all sides with padding. And let's get this controller out of here. Dun dun dun! So it's in an anti-static bag. And I got my little sticker for my machine. Here it is. This is the Masso G3. Like I said, the 3rd generation product from Masso. Masso is a Australian company, but this is kind of designed by Hyatt Technology, which I think is an Indian company. All right, let's go through some of the quick. There's a lot of videos on this thing. I'm just going to go ahead and give you some reasons why I ended up buying this over just what I have in the garage already. 18 TTL inputs. We have full spindle control here with PWM X, Y, and Z, and then we also have the capability of doing A and B axis, so this will run 5 axes simultaneously. And I have 24 inputs across the top. You might think, well, what are you going to use 24 inputs for? But it turns out that there's a lot of functionality that you can just have a hardwire switch for on your control panel. So things like cycles stop, cycle start, rewind, go to some G28 position, homing sequences, all that kind of stuff in the configuration thing here will say, if the TTL level is low, then go run this particular functionality. Or you can have it run a macro file, which actually will pull a G-code file off of the USB. So like one thing I do on my machine out in the garage a lot of times is I need a tie down point at a specific spot on my spoiler board for an insert. So I just move to that point, 0Z, and then over here I'll just hit a button and it will cut the circle out so I can thread that insert into my spoiler board. Over here we also have 3 encoder inputs for A, B, and Z. We also have 2 analog inputs that aren't kind of defined in their functionality yet in the firmware, and an E-stop switch here. And these are all color coded, as you can kind of see. So the power ones are red. This one's spindle control, and the rest of them are green. These are removable connectors, so they do come out. So if I need to pull the controller out for some reason, do a firmware update or something, I don't know what I would be pulling. Let's say it's failure, which that's going to happen. But I could pull all this out and not have to unwire my machine to put a new controller in. That's a nice feature. It's also nice if this is down in your enclosure and you're doing some wiring, you could pull out the connector and wire it outside the enclosure and then plug it in. That's an actual nice feature. On this side over here we have 4 USB ports, a VGA port here. The VGA currently supported is 1024 by 768. It's kind of small, but this is an embedded system, so they're doing a lot of graphics hardware, graphics manipulation, frame buffers and that type of thing in the RAM. So it's somewhat limited. But if you watch any of the other videos, or if you watch some future videos here, you'll see what this graphical interface actually looks like. It's certainly better than one of these stupid little displays that I have on my machine now. Over on this side I have a connector for MPG, which is a pendant. I can just plug it right in here. And all these connections here are the wiring schematic is known, so I can make my own jog wheel or whatever and have it wired into this DB15 connector, and then I have an additional I/O connector here which brings out these pins onto a different type of header. Okay, it's on a DIN rail mount, which is awesome, so I can just kind of clip her in, and that solves any kind of mounting issues. This runs up to 24 volts, which is good. I'd prefer to run a little higher than that, but it's okay. 24 volts is going to work fine. For connectivity, if you look also in the box here, it looks like what's in this. Oh, this is an external Wi-Fi rubber ducky antenna. All right, so inside of here they have an ESP1. It's an ESP8266 board. There's a connector right here underneath this plate, and you plug it in, and then this Masso will offer its some of its services over Wi-Fi. Things like I can upload files onto the USB key. All the files that it's going to operate with are on USB, so I can upload stuff over USB, over Wi-Fi to the USB, and then I can actually check on progress from a remote location. So in the configuration screen here, you set up what your Wi-Fi credentials and whether or not you want to use a DHCP or you want to do fixed IP addressing. Okay, well that's it for here. This actually looks all really good. Let's go ahead and put this back. And I think this is going to be great. I am looking forward to this, so that I can just go out to my machine, turn it on. This thing boots in about 10 seconds. Turn it on, have it boot up, do my work, and upload files from Fusion, and do everything on the machine that I need, and just turn it off, and not be booting a computer or not be booting anything else. And one of the use cases of my Hyatt machine is to have my granddaughter come out and make some parts on it with me. So I do want something that doesn't have too much overhead from a machining standpoint to get started for her when at her particular age. All right, let's go back over to the desk. Okay, so if you're still here at the end of this video, you're going to see a few more videos of me doing the install. So I do have an enclosure coming. I have some DIN rail. I have some terminal blocks, some other functionality that I'm going to be mounting, and so we'll go through and do a controller replacement on my Hyatt machine in the shop, and we'll kind of deviate from my normal work here in the valve studio to actually get that thing running, because one of the lingering projects here is to make these speaker cabinets for the top row of my bench here. So that's it for now. Thanks for watching.